Hi everyone, welcome to your homework help video for Chapter 7, Final Test Study Guide. Question number 1 says the probability of an event is 85%. Describe the likelihood of that event. So remember back when we're talking about the likelihood of an event, it's basically a scale 0 to 1. 0 is like impossible. 1 is guaranteed, or it's like a sure thing. A 0.5 is equally likely or unlikely. And then we would say anything between 0.5 and 1 would be likely, and anything between 0.5 and 0 would be unlikely. So probability of an event being 85%, that would be 0.85. 0.85 would be over here somewhere. So we would say the likelihood of that event, that it is likely. For number 2, you randomly draw a marble from a bag, you record its color, and then you replace it. You draw a green marble 7 out of 25 times. So what is the experimental probability that the next marble will be green? So we're going to write this as a fraction, 7 out of 25, where 7 is a win, basically. That's a favorable event, and 25 is the total number of times. So 7 divided by 25 is 0.28. So the experimental probability would be 0.28, and some of us like to say 28%. There are 12 blue marbles and 23 yellow marbles in a bag, and you randomly choose one of the marbles. What is the probability here of choosing yellow? So first of all, we need to understand that there's 12 and 23. So 12 plus 23 is 35. That's the total number of possible outcomes. And it then asks, what's the probability of choosing yellow? So that would be 23. 23 divided by 35 is 0.65, or actually if we round, 0.66, or 66%. For number 4, use the table to predict the number of times you will spin 4 when you spin the spinner 100 times. So we first of all have to look just at our data that we're given in this table. There are not 100 spins here. In fact, we have 3 and 5 is 8, 10, 16, so we have 20 total. That's the total number of outcomes in our trial or our experiment. Use the table to predict the number of times you will spin 4. So we want to look specifically at this right here. 6 out of the 20, 6 are favorable, 20 total. So we'd go 6 divided by 20 is 0.3, or a 30% chance. 30% chance when we did 20 trials. We now need to do 100, so we'll take 0.3, expand that times 100, and 0.3 times 100 is 30. So we would say that there would be 30 favorable out of 100 total. For number 5, you choose between red, blue, or green wallpaper and purple, blue, or yellow carpet. Find the total number of possible outcomes when you select one color of wallpaper and one color of carpet. So the easiest way to go about this is to do our tree diagram. We could choose red, blue, or green wallpaper. If we choose red wallpaper, we could still choose purple, blue, or yellow carpet. If we chose blue wallpaper, we could choose purple, blue, or yellow carpet. And if we chose green wallpaper, we could choose purple, blue, or yellow carpet. So now you could see that there are going to be 3, 6, 9 possible outcomes. Another way to calculate this without drawing the tree diagram is to recognize you had 3 possible outcomes for your first choice, 3 possible outcomes for your second choice, and 3 times 3 is 9. You roll a 6-sided number cube and you flip a coin. What's the probability of rolling a number less than 3 and flipping tails? So for this one, I think a tree diagram or a table is going to be your best bet. You roll a 6-sided die. So we have 1, 2, 3, 4, 5, 6. And then you flip a coin. Heads, tails. We can clearly identify here that we have 2, 4, 6, 8, 10, 12 possible outcomes. We need to decide how many are going to be favorable. For the outcome to be favorable, it says we need to roll a number less than 3, so that would be 2 or 1, and you have to flip a tails. So it could be 1 with a tails or 2 with a tails, meaning there's only 2 possible ways that you could get a favorable outcome. 2 out of 12 is 1 out of 6, and 1 divided by 6 is 0.16 repeating, or 16%. For number 7, you choose 2 different candies in a store at random. Out of the 15 candies at the store, 6 are chocolate bars. The first candy you choose is a chocolate bar. What's the probability that the second candy is also a chocolate bar? Okay, so 15 candies. That's going to be our total number of outcomes. 6 are chocolate. So the probability, this is your favorable outcome and your total. 6 out of 15 is going to give you a probability of 0.4. But now you are going to run this as a compound event where you're going to pick 2 candies back to back. The chance of picking a chocolate bar here is 0.4. The chances of picking another chocolate bar is 0.4. So 0.4 times 0.4 is 0.16, or 16%. And you could say that would be unlikely that you would pick 2 chocolate bars back to back. In question number 8, a treasure chest contains gold coins and gemstones. There are 105 items in the chest. Picking a gold coin has 4 times as many favorable outcomes as picking a gemstone. How many of each item is in the treasure chest? So what we need to do here is we need to set this up as an equation. We know there's 105 total items in the treasure chest. We need to use the same variable, okay? But what we know is gold coins has 4 times as many favorable outcomes. So we're going to say this is 4 times X. X equals an item in the treasure chest. 4X specifically represents the gold coins. And then a gemstone would be represented by just X. So now we can solve this through combining like terms. 4x plus x is 5x. 5x equals 105. Dividing both sides by 5 gives us x equals 21. So gemstones would be 21. Gold coins is 4x, so 4 times 21 is 84, and 21 plus 84 is 105. So we'd have 21 gemstones and 84 gold coins. On to number 9. You roll a number cube and you record an even number 8 times in a row. Okay, so while this is very unlikely, you could technically roll an even number 8 times in a row. It's a 6-sided die, and there are 3 even numbers, 2, 4, and 6. So you have a 3 out of 6 or a 50% chance, so 0.5 for all of these. So if we were figuring out the theoretical probability, 0.5 times 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 0.5, you are going to get a tiny, tiny number, okay? Like 0.0039. Not even a 1% chance that you roll an even number 8 times in a row. However, let's look at the next part of this question. As the number of times you roll an odd, now an odd, so odd would also be 3 out of 6. As the number of times you roll an odd increases, what happens to the theoretical probability that you roll an even? So I think we need to actually just get rid of all that, because that's all just kind of nonsense right now. In fact, if you look, each time you roll, isn't the probability always the same? It's always 0.5. It's always a 50% chance that you roll an odd, a 50% chance that you roll an even. So, as the number of times you roll an odd increases, that also doesn't matter. Because if we say an odd is a 3 out of 6, well, so is an even. It's also a 3 out of 6. So therefore, we could say, what happens to the theoretical probability that you roll an even? Explain. Nothing changes. In fact, it's always 50-50 or 0.5 no matter what. And it never changes because one roll of the die does not impact the second roll of the die. Okay? So the thing we want you to know is with theoretical probability, in theory, it's always going to be 0.5 for this scenario, and one roll never impacts the other. For the last question of your study guide, number 10 says the tiles shown are placed in a bag, and you randomly select one of the tiles, return it to the bag, and then randomly select another tile. What's the probability that the first number multiplied by the second is greater than 0? So let's go -3, -1, 2, and 3. Each one gets put back, so you could have a -3, a -1, a 2, and a 3. And the same goes for all trials. -3, -1, 2, and 3. -3, -1, 2, and 3. Okay, so it says, what's the probability that the first number multiplied by the second is greater than 0? We have 4, 8, 12. We have 16 total possible outcomes. And we now need to identify any outcomes that will have a number greater than 0. So 3 times 3, negative 3 times negative 3, that's actually positive 9. Negative 3 times negative 1, that is 1. But negative 3 times 2 is negative 6, and that's negative 9. So up to this point, we just have 2. In our second, we have negative 3 times negative 1. That is positive 3. And negative 1 times negative 1 is 1. And then in our third, we have 2 times 2 is 4. 2 times 3 is 6. And 3 times 2 is 6. And 3 times 3 is 9. So those are the possible outcomes that would be favorable or that would result in a number greater than 0. So we've got 2, 4, 6, 8. 8 out of 16. That is 1/2. That's 0.5 or 50%. So it's equally likely that when you multiply the two tiles together, you would get a number greater than 0 compared to less than 0. And that wraps up the Homework Help study guide. If you need further assistance, please talk to a parent, a friend, or ask your teacher for help. Good luck on your test.